Okay, so here we have the third exercise. In this case, we don't need to draw the graph. They already give us a graph like this, okay? So the first question is, what kind of movement is it? When you have a graph, to notice the kind of movement, you already know in the presentation, the different graph that corresponds to the different kind of motion. In this case, we have a graph that is a horizontal line, but it is very important to see what we are representing. In this case, we are going to represent the speed, okay? And the speed is an horizontal line. Okay, if you remember, that graph is the graph of a uniform motion. In this case, we have a uniform motion because the graph of a speed is an horizontal line. This means that the speed doesn't change. We have at the beginning a speed of 10 meters per second, then it is still 10 meters per second, 10, 10, 10. At every time, the speed of this motion is 10 meters per second. If the speed doesn't change, it means that we have a uniform motion, okay? So that is the answer to the first question. Then, they ask us what is the acceleration. You don't need to calculate anything in this case. If you know that it is a uniform motion, the speed doesn't change, that means that there is no acceleration. The acceleration is 0. Third question, what is the distance traveled? Okay, in this case, you need to make some calculation, okay? I remind you that to calculate the speed in a uniform motion, we have the equation of the mean speed. That was the equation. The mean speed, in this case, in the case of the uniform motion, the mean speed is the same than the instantaneous speed because the speed doesn't change. Well, the speed equals to the distance traveled divided by the time. Okay, we know the speed in all this movement is 10 meters per second. So the speed is 10 meters per second, and they ask us about the distance traveled in 5 seconds. So we know the time. The time in this exercise is 5 seconds. So we need to know the speed, 10, and the time, 5 seconds. The speed is in meters per second and the time in seconds. So no problem with the units because we have just one unit for its physical quantity. In this case, for the time, we just have the second. So what we need to do is calculate the distance traveled. So we need to take the time to the other side of the equation, multiplying, okay? So the distance traveled equals the speed multiplied by the time. So in this case, the distance traveled equals the speed multiplied by the time. This is the speed, 10 meters per second, multiplied by the time. They ask us about the distance traveled in 5 seconds. So 10 multiplied by 5, 50. 50 what? They are asking us about the distance traveled. We are calculating the distance traveled. So this must be a unit of time. A unit of distance. What is the only unit of distance we have here? Meters. So the answer is 50 meters.